So now you got a fairly good understanding of the underpinning of what is time, what is science, and we're going to go on to learn more about how the geologic timescale was developed and who did that, and how the ideas that went into it became part of our understanding of geology, and how they used absolute age dates, not so much, but lots of relative age dates in order to figure out this sequence of events that ever happened on Earth. It's so kind of profound in many ways. So we'll go on with that. Thanks.
I always love photographs that are a little perplexing, perhaps. This is the cliff dwellings that is at Montezuma's Well in Arizona. This is a little bit north of Phoenix, and it's a freshwater spring essentially right here. And I think about what's the future going to hold for a place like this. So if you have sediment that eventually is going to cover this up and become lithified, they're going to find human remains and, well, at least the dwellings of humans embedded in these rocks. And of course, they could make the mistake that that would actually be an area where humans lived at the time of these rocks. Now, fortunately, these rocks are actually mostly either Pleistocene or Holocene in age. They're carbonates, actually, that would have been deposited during the flow from the spring, so it wouldn't be too far off of the mark in order to preserve them as such, and so they wouldn't be, the future geologists are not going to be too puzzled by that, I suppose. Oftentimes, when we look at the geologic time scale, as you know, there were 4 columns that are not the same scale for each column. In fact, every column is a different scale. And there's another way that people have illustrated this. This is from the U.S. Geological Survey. This is a spiral of time, and it starts at 4.5 billion years at the very tip of the point down there. That's the beginnings of Earth. And then they show you the different ages. And so they don't list the Hadean on here, but here's the Archean, and then there's the Proterozoic, and then next thing you know, you're up into things like jellyfishes that are swimming around in the oceans back in Precambrian time, late Precambrian time, late Neoproterozoic. And then eventually you follow the spiral upward, and you can see the Paleozoic, the Mesozoic, and then eventually the Cenozoic here. And here we are at the end of time. Yeah, we are at the end of time right now. And it's going to expand a little bit, for the rest of the day here, and then go on to next month and so forth. So actually we're in August now, so we're already in the next month. So with this sort of design like this, why would they take a spiral? Well, the rationale for that is that all of the living creatures that we know of have either RNA or DNA as the building block for which they evolved. And so even viruses have RNA, like the coronavirus right now is replicated through RNA and ribonucleic acids, right? So DNA, of course, is what's in every animal and every plant pretty much. So it's the one thing we have in common with every living creature on this planet. So that's why they did it with the spiral there. Okay, so really we're trying to talk about the history and the development of the geologic timescale. So here is a photograph of Adam Sedgwick. Adam Sedgwick was one of Charles Darwin's mentors, along with Charles Lyell. But Charles Darwin, the famous, naturalist on the HMS Beagle, this is his teacher. And they actually took a trip together to North Wales and studied some of the Cambrian rocks there. Well, as it turns out, Adam Sedgwick is the first person to propose the title Cambrian Period for rocks that bore trilobites. And so they were some of the earliest fossils that existed. And it was Adam Sedgwick who came up with this idea that, they only existed at that time, perhaps. Now, he was a catastrophist, but he had a very good friend. His name was Roderick Impey Murchison. And so together, Adam Sedgwick and Murchison proposed the Devonian period because Murchison had seen Sedgwick's work on the Cambrian. And well, this is interesting. And so they proposed together the Devonian period, named for Devon in the south of Britain. So both of these periods had key fossils, and that's how they recognize these strata. So if you go out in the field and you find certain fossils, then you can say that you're in a certain time period, or rocks that belong to a certain time period. And they knew that. So Devon is in the south of Britain, as we say here. Cambrian comes from the Latin name Cambria, which is the Latin translation for the Welsh word Gymru. And Gymru is the name for Wales from the Welsh people. And so that was the derivation. And in fact, even in Wales, they have what they call the Cambrian Mountains there. And so they're kind of the backbone that runs through the entire nation. Murchison is the fellow at the left here, and you can see he's a Scot again. Sedgwick was English. He proposed the Silurian Period, and that was named after a Celtic tribe who lived in Wales along the borderlands in the southeastern part of the country. So the Silurs were the etymology for the name Silurian. And of course, he co-authored the name Devonian Period, and that's for old red sandstone that crops out in Devon. And it also crops out in Wales as well, and much of Britain also. And so they traced these strata. They could trace the Silurian and the Cambrian around the entire island of Britain. And what you find is that as they were doing their work, they found rocks where they couldn't decide. Murchison considered these to be Silurian rocks, and of course, Sedgwick had considered them to be Cambrian rocks. And so they had a controversy about this. They called it the Cambrian-Silurian controversy. Where does one stop and where does the other one begin? And so Murchison, they had a falling out over this, in fact. They were so vehemently, opposed to the other's ideas that they couldn't even speak to one another. And so what they wound up doing, actually, they just kind of parted ways. And Murchison went off to Russia to work in the Ural Mountains and a little bit east of the Ural Mountains. And there he described some rocks that became the defining rocks for the Permian period. And so all of a sudden, already in this history, you've got Sedgwick with the Cambrian, you have Sedgwick and Murchison with the Devonians, Murchison with the Silurian, and then also now you have the Permian, and that's another Murchison contribution to our understanding of what defines the Permian in this case. That's the ancient kingdom of Permia, or it's close to the city of Perm in Russia, a little bit northeast of Moscow. Now this map shows you some of the namesakes for the British areas anyway. This is the Cambrian Mountains that stretch across Wales there, you can see. A little bit right of the circle, where the circle is just on the Llyn Peninsula there, but that's the Cambrian Mountains that stretch behind the Llyn Peninsula all the way over to North Wales and all the way into Mid Wales there. You can see the Ordovici, and they are a northern tribe, okay? And so there's the Silurs as the ones down at the bottom down here, and there's Devon at the very bottom down here. So that's the namesake areas for each one of these tribes. And the times that go along with them in geology, that's where those rocks crop out. So with Charles Lapworth, he came along and he says, I can settle this controversy pretty easily. And he proposed a compromise that the rocks that were in between the Cambrian and the Silurian should in fact become a new time unit called the Ordovician, named after the Ordovici tribe, of course. And so they fell in between the Cambrian and the Silurian. As you know it now, those are the rocks that you will see and that you will memorize as the Ordovician period. So it was a compromise by Charles Lapworth here that led about to the proposal for having an Ordovician period. So that was a tribe that was pretty much wiped out by the Romans. Caractacus was the commander of the Ordovices, And it was the historian Tacitus that tells us these tales. And so these are the folks that would paint themselves blue and run out of the mountains and have, what do they call them? Berserkers, I think it is, to be able to attack the Roman army as they landed. That was really early on in the Roman occupation. Now, the Romans were there for like 400 years. But that was in the AD 60s and AD 50s, 60s, and 70s. So that only leaves us a handful of time periods in the Paleozoic to still go over. And the person who described the Carboniferous, there were two folks that were responsible for that. That's Conybeare and Phillips. And so William Conybeare and William Phillips here in 1822 proposed the idea of a Carboniferous, and that's mostly for the coal measures. And the rocks that were just below the coal measures were actually known as the Dinantian. And so the Dinantian was never proposed as an official name, although many people recognize the lower Carboniferous as Dinantian. And so that is named after a small, well, I think it's not so small anymore, but it's a town in Belgium on the Meuse River. And so you can see on the lower left here, these lower Carboniferous rocks cropping out behind the cathedral there at Dinant in Belgium, southern Belgium. And so on the right-hand side, this is a place I got to visit in South Wales in the coal measures there. That's Penny Van, the top of a mountain here, and these are all sandstones for the most part here. The coals are a little bit lower down in the succession here. And so what you see here are the rolling hills that have been glaciated somewhat in South Wales. So those are the coal measures, and so that was the derivation for the name Carboniferous. Now, Phillips is going to show up again, with some other names, and so Phillips actually proposed the terms Paleozoic, Mesozoic, and Cenozoic, or Cenozoic as we know it today, in 1840 and 1841. He actually published the first geologic timescale. So William Phillips, we can thank for that. Now, those weren't official proposed names because there's no place where you can go to, say, study the type Paleozoic. So they don't have the same significance as the time period so much, or as the systems. And then we'll talk about the difference between what a period is and a system. But the ideas, however, were profound. And so Phillips gave us those ideas of things larger than just periods or systems. And so we call those eras or erathems. And in America, we had a different sort of history for those rocks. And so people who lived and worked in Pennsylvania knew about the coals that were there. And so they named these strata the Pennsylvanian. And so that's the upper Carboniferous. The Mississippian was named by Alexander Winchell, and that's the fellow on the left here, and he named those for the upper Mississippi River, where they crop out around Keokuk and also the Quad Cities area in the eastern part of Iowa. And so the person responsible for naming the Pennsylvanian was Henry Shaler Williams. Today, we recognize the Mississippian and Pennsylvanian in North America as subsystems of the Carboniferous. That concludes the series of different Paleozoic time periods. And actually what these guys were doing, they weren't quite looking at time, of course. They were looking at rock and collecting fossils. And so there is a connection between these, of course. And so if you have a time period, there are going to be rocks that were deposited during that time period. So we actually use two different names for that. So for time, we use period. And for the time rock units, we call those systems. And so if the Cambrian period is a certain time in Earth history, then the Cambrian system are those rocks that were deposited during that time period. And so for each one of these, for each period, there's going to be a system. And that's a place on the ground where you can go and compare what one system looks like, in one area, and then compare it to another area. And so the IUGS and the International Commission on Stratigraphy is really responsible for trying to select those sort of like examples for where people can go to compare to the type area or the type section, if you will, for these rock units. And so that's the time rock units, in fact, here. And so you see a list here. So the periods are time, the systems are the time rock units or chronostratigraphic units, and they serve as a standard, okay? And so all of those periods together equal the Paleozoic era, the ones that we've talked about so far here. And so, but the rocks themselves, there's no place on Earth where you can go to see the entire succession, I think, of Paleozoic rocks and have that be an example. But you would call that interval, if you found those rocks somewhere, you would call that an erathem. And so this just kind of illustrates what the difference is between time units and time rock units. So let's go on. And we're going to talk about this as though it's time, even though these guys were looking at time rock units. So that's really the Mesozoic erathem. That explains where that comes from. But the Mesozoic era is that time period. So if we start in the Mesozoic, or Mesozoic, as my British advisor used to call it, in that interval, you would have the Triassic at the base, and then the Jurassic, and then the Cretaceous above that. And if you didn't get it already in the Paleozoic, it's the Cambrian, Ordovician, Silurian, Devonian, Mississippian, Pennsylvanian, or together the Carboniferous, and then the Permian after that. And so that's the succession so far. So in the Triassic, that was named by Friedrich von Alberti, and he recognized a threefold division of these rocks in the foothills of the Alps, 1834. So you can see von Alberti in that early photograph there. The Jurassic strata were named for the Jura Mountains in the south and east of France, and they were recognized by William Smith as the Oolitic series in Britain, but it was Alexander von Humboldt in Germany in 1795. And really the person mostly credited for this, for the Jurassic, is Alexander Brongniart. So he proposed the term Jurassic, but it was von Humboldt who studied those in Germany, and they were named for the rocks in France and on the border between France and Switzerland. Christian Leopold von Buch spent his entire life studying those rocks. And so I've included him here as a etching, if you will, to show who he was, because he's one of the more famous guys who have worked in the Jurassic. For Cretaceous age rocks, we go to Belgium, and this is Jean-Baptiste Julien de Amolius de Hoye. And de Hoye, he studied the chalks around Paris, and that's actually where the name is derived from. So Creta is for chalky. And so those are the same rocks around Paris that you would get, in fact, on the White Cliffs of Dover. So you will see photographs of all the White Cliffs of Dover later on in the semester when we go through our time survey and looking at rocks around the world. So very famous cliffs, the White Cliffs of Dover. So that's the Mesozoic right there. If we go on to the Cenozoic, the Tertiary, as you already know, was named by Giovanni Arguino. It was that third series of rocks above the primary and secondary rocks, and tertiary means 3. Quaternary means 4, of course, and he proposed this idea, but it was actually officially named by Jules Denoyer of France, and that was for rocks around the Seine River basin, close to Paris as well. So finally we get to these upper rock units, these upper time periods. And so the Paleogene and Neogene, which we didn't use those in North America too much, but they did use them in Europe. And so it's important to recognize them. Moritz Herns from Austria is the guy who proposed that term, these two terms, Paleogene and Neogene. Now, when it comes to the epochs that compose these sort of rocks, there's a whole bunch of different people who have proposed these names. And so, in fact, it was Wilhelm Philipp Schrimper who came up with the name Paleocene. Okay, so what that really means is ancient. I think it actually means ancient modern. Okay, so this is a modern time period, this Paleogene, right? It's within the Cenozoic, in other words, but in fact, it would be the oldest of those. And so Schrimper referred to it as the Paleocene. Now, in his textbook, Charles Lyell, I didn't put in his photograph, you've already seen his image before, but he's the one that came up with the succeeding names, most of them anyway, and that was the Eocene, Miocene, Pliocene, Pleistocene, and the recent time period. Now, I skipped over the Oligocene there, and that was actually proposed previous to his publishing this, and I don't know if he even recognized it, in fact, but Heinrich Ernst Berich it actually proposed this idea of the Oligocene, and it means kind of like scarce or scarcity. I think it's a scarcity of fossils in the Oligocene where it was first described. So Berich is the fourth person in this series of portraitures at the bottom here. And now finally, if Lyell had proposed recent as the most recent time period, and that would include perhaps the after the Pleistocene, you would have the Holocene, right? And so for Holocene, that wasn't even proposed by a person, actually, and that was kind of presented to one of the first early geologic conferences and congresses that met in Bologna, in fact, in 1882. And the term Holocenes was presented at that meeting to replace the term recent, which Lyell had introduced. Today, when we talk about recent, that's probably not accurate to be a part of the Holocene even, in fact. And so, but Holocenes was first presented by a group of folks at this Second International Geological Congress, and then they called it the Holocenian at the Third Geological Conference, and that was held in, I think it was in Lisbon. It was in Portugal. Anyway, it was Portuguese who actually presented it, but the meeting was in Berlin. But anyway, that's our whole entire time scale, essentially all the names that you're supposed to be recognizing here. So I want you to keep in mind that this is always in flux, especially the absolute age dates. And so the ideas about the geologic timescale have changed. And in fact, there's still some arguments going on about what do you do with the Quaternary. And so for the time being anyway, Quaternary now refers to a combination of the Pleistocene and the Holocene together. And in fact, people have recently subdivided the Holocene into three time periods, if you will. So if those are series, you would divide them then into stages. And so the latest stage happened about 4,200 years ago, I think it was, from present today. So these ideas change. It's all decisions made by committees, it seems like these days, and they're mostly populated by Europeans and Asians. And North Americans we've kind of run our own way for a long period of time. For a long period of time, we used the Tertiary and Quaternary in this country, and they mapped the entire western part of the United States, and they called it Tertiary Volcanics because they were that common, and so it was a map unit that was called TV. So what are you going to do to fix all those maps if you take the term Tertiary out? But that's exactly what they did at the IUGS. They've deprecated the term Tertiary. So now they just refer to it as Paleogene and Neogene, of course. Paleogene is the older rocks, and then Neogene, the younger rocks, of course. And so those would have been the Tertiary, everything that's below the Quaternary, in other words. And so that's part of the discrepancy, It's like, so what do you do with the Tertiary? So you will find it still included in the GSA timescale, at least for the time being. Now, that said, and I mentioned that they've divided the Holocene into three parts now, and the last one was just proposed and ratified actually in 2018. And so that includes everything since the Holocene includes everything since the last ice age. And so what we really have now is a major discussion of, since the 1970s anyway, about a new proposed series, or a new proposed epoch, if you will, and people would like to refer to it as the Anthropocene or the Anthropocene. And it was a term that was proposed by Eugene Stermer, and he actually just he was interviewed about this, and he said he just made an offhand comment. It's like, no, human beings have this huge impact on Earth's sedimentation and Earth's history. We need to recognize that, And so it's the Anthropocene. And actually that comment wasn't remembered and recorded, and some people had used it informally, but it wasn't until the 1980s that Paul Crutzen got a hold of that, and he says, this is really a valid idea. And so in the last 20 years, people have argued about this. And so there is a proposal out there to say there is a human impact on the sedimentary record. So what I would like for you to do is to look up the Anthropocene on Wikipedia, read a little bit about it, and you decide. What do you think? Can you actually be living in a time period and then have it proposed to be named after your species? There's a lot of, good that can come out of it. The good is that, we look at this as, is it driven by climate? Is it driven by human endeavors? Like maybe, like one of the proposed horizons that would mark the base of the Anthropocene would be the first nuclear detonation. And so that left a telltale marker in many of the sediments around the world, because they were open air detonations, some of the early tests, and also the ones actually used in war. So the Anthropocene is going to be the newest chapter. You should probably know the name. It's not been ratified yet, so it's not official. So with that is the history of the geologic timescale as we know it today. So I hope you enjoy that. Yeah, it's a fascinating sort of history that goes along with this science that we have. So every single scientific paper that's published in the geological sciences, pretty much you always state what the time period is you're looking at, so people have a good frame of reference. And so that's what this course is designed to help you with. And so, so if I talk about Pennsylvania, we're talking about coal swamps and things like that. And then when I talk about Permian, we're talking about that's Pangea, and there were desert conditions around much of the world. When we talk about the Mesozoic, we're talking about the age of dinosaurs, and we're talking about, deserts across much of the world at that time as well, but also the breakup of this Pangea giant supercontinent that we had. So that's the sort of framework we're going to have in here. So I'm going to leave it at that, and good luck studying the exam for this. There's 59 points, right? So there's like 35 different names, and there's 24 different age dates for the boundaries between some of the more important time periods that are recognized. So, all right, I'll leave you with that, and hopefully you'll enjoy this. Thanks. Bye now.